Hello everyone. We should finish the theory for chapter 9 that is talking about the sets and about the pickles. So if you are familiar at all with the mathematical notion of set, such as you took Math 102 or a similar class, you have an idea what is this going to be about. So for a set, all items must be unique. That is, the you cannot have on the same set 2 and another copy of 2. Sets are unordered, which is the opposite of what we had in a list. Also, in a list, we could have 2 copies of 2. And elements can be of different data types. So we can create an empty set using a set function, or a non-empty set with an argument where argument is an object that contains iterable elements. For example, a list, string, or tuple. Try doing it with a string, you'll see an interesting behavior there. But in general, I would use a list. So if argument contains duplicates, only one of the duplicates will appear in the set. And we can use length function, add method, and update method. I think it is best if I just start an idle and show you some examples in real time. Okay, my set A will consist of 3 elements. For example, capital A equals to 1, 2, 3. And set B consists of 2, 3, 4. First of all, let's look at set A. This is what it is. That's one way to denote them. Set C can be an empty set. And sorry, let me show you how the empty set is referenced in idle. For example, we can use length of set A. That will be 3, of course. We should add an element to set A. For example, add 4. Let's look at A. It has a new element now. A dot remove 4 will restore our original A. There is also an update method to throw in a bunch of elements. There is also this way of making a set out of the list that I was talking about earlier. So we have a list and we are turning it into set, and just for fun I'm gonna add a couple of 2's there. In the end, let's see what set C, capital C, will be. So capital C consists of the same elements with no repetitions. Now it's important to stress that you can see about the same order for the set as you would see originally the new elements appear on this list I produced it from. However, there is no ordering to this, and if you were in some program updating this set C a lot, such as adding elements, throwing away elements, and then you print it, you might get elements in a different order. So do not presume that the order will always stay the same. Now there is a slight difference between remove and discard, and I guess I just want to show it from the slide. So remove, I just showed you how it works on a set. However, remove will throw k error in case the element is not in the set, and discard will not do that. For different purposes, you need to think which one will fit better. For example, if you want to remove an element from user input, user gives an element and then you remove it from a set, then discard is better because who knows what the user will type in, whether this element is actually on the set or not. And in many other cases, if your program is in business of removing elements which are not there in the first place, that may mean that you are off in your logic, and you may want to use remove to make sure that when it removes something, it actually does something rather than does nothing like discard. So you use there is enough problems to use each of them. Okay, now continuing with my examples, I will use a couple of loops. Before the loop, I will show you that you can check if 10 in capital C, it returns false. So this can be used in your if statement. If some number n in C, then do this, else do that. And we can also iterate through the elements. Again, there is no order, but there is ability to iterate. For x in capital C, I would say print x. So it prints the elements of x. Now here is a little warning for you. Let's look back at set A or set B. And if I were to try in a loop to add elements to set A while iterating through set A, that would throw an error. And you can try doing that. So for x in A, colon A add some new element like 2 times A, 2 times x. And that would throw an error because while iterating through a set, you cannot also change it, and you can work around by having a temporary, you can have a workaround by having a different variable to add elements to. Okay, so let me restart the idle again, and we will talk about what the sets are for. Okay, so my A is 1, 2, 3. B is 2, 3, 4. And for example, I want to do A dot union B and see what that is. That is a set that consists of elements from each of the set. And again, the duplicates are ignored. We can also do symmetric difference. Oh, by the way, you can produce the same result with a vertical line. That is a union as well. You can use a difference B with a word dot difference, or you can do a minus B, and that will be all these elements in A which are not in B. There is only one such element that is in A and not in B. There is also a notion of symmetric difference, which returns all elements which are in one of the sets but not in both. And of course, there is a notion of intersection. Intersection can be, in short, denoted like this, and B, or you can say A dot intersection B. So both are interchangeable. So for your set, you can do differences, you can do unions, intersections, and that is set operations for you. So this is a nice little data structure that you can be using. And I should also explain what is a subset. So A less or equal to B will return false because A is not a subset of B. Subset means every element of A is also element of B. That is of course not the case. My A contains something that is not in B. However, if I consider a set consisting of 3, it is a subset of A. This is a set consisting of single element. This is a set, and it is a subset of capital A. So that you can also use subsets. There is a symmetric notion of a superset, but that is not a big deal. All right, on to serializing. One more topic that you may find very relevant to your final project. Serializing an object. So convert the object to a stream of bytes that can easily be stored in a file. In Python, we call it pickling. They call it pickling, as in preserving cucumbers. It's easier than saving variables to a text file, which I may have done at least in some sections earlier. That is because it is saving it exactly as it is. Pickling saves it exactly as it is. So you need to import Pickle module, and you need to open a file for binary writing. I will show you an example in a moment. And you can call pickle dump function to pickle an object, whatever that object may be, to a file. And then you need to close a file. So there are some similarities with how we worked with text files. We need to open a file and close a file. And we can also do pickle load, which is loading an object from a file, and since you did that, you would have to store it in a variable. Don't forget that. Otherwise, you really didn't do much. Okay, so let me do an example about pickling, saving, and loading. All right, so this is a pickling example for this video. I have example dictionary. We have two key value pairs. One is the key, value is 2, and another key value pair, key is hello, and value is world. And also an example list, which is 3 times repeated ha ha ha. And we want to save it. This is just the starter. To save it in a pickle. Pickle files will have .dat extension, and then we also want to load it and play with it if we like. Okay, so that again you may find very relevant to your text game. That is, you can use keep all your variables about the player, such as player name, player stats, in a single dictionary, and all you need to do to save and load is just pickle and unpickle. Okay, so I will import pickle and I will work on my save function. All right, I wrote my save function. X is the object that we are going to pickle. I'm asking for a file name as previously, and the extension for the file name will be .dat. It can be an existing file or a new file. In any case, whatever was in there will be written over. And I'm doing f open file name .dat, and then I'm dumping my object into the file and closing the file. Alright, so I saved my file and now I'm running this for the very first time. And so I clicked run on my Pickle example, and now I'm calling the function save with example dictionary, which is an example variable that I created earlier. To make sure that we actually create a file, and then now it will ask me for a file, example pickle, and something must have happened. Let me open the appropriate. have a look. In my folder, this is the py file, Pickle example, and I saved a dot file, Pickle dot. Now you cannot easily open it, and you don't need to. This is just a binary file. And now we should be able to unpickle it after we write our second program. And here we will need a return statement. So after we loaded something from the Pickle, and we don't need a variable x, we're just loading it, we need to return it, and when we're calling load, we will need to have a variable for the result of this function. Other than that, it is about the same, so I will need to specify the file. Okay, let's talk a little bit more about syntaxes here. So file name will be a string plus dot dot will be a file name with extension dat. And I'm opening in case of save for write in binary, and in case of load for read in binary. Write binary will overwrite the existing file if it exists, so create a new one. And in case of saving, I do pickle dump the object x, and I'm dumping it in file f, file object f, and then the actual writing happens when I close the file, so don't forget that. And in case of load, it's about the same. So open for read in binary, pickle load f, close it, and then return the variable. Unless you return the variable, and oops, here we go, my x should be pickle load. Okay, so unless I do save it as a variable, I cannot reference it from outside of this function. Now let us run and play with it. So first of all, I want to load. Load parentheses, enter a dot file name. I need to look at my file name. Let's try Pickle example. Okay, that may be a naming error. Just a moment. All right, let's try again. It was a naming error indeed. Example Pickle was the name of the dot file. And here it prints out. Now this is almost good for the sake of your final project. However, in your final project, you would have to actually make this result of the function equal to a variable. For example, example dict will be equal to load from that file. So again, I need to enter exactly this name. And now I'm trying example dict. And indeed, it has loaded. It is what we expected it to be. Now we could actually create something else, create a new object and create a new file, but I'm fairly confident that this works. If you like, feel free to play with it a little more. And remember, there is a difference. Here we take an argument, and in the load we return an argument which has to be caught by a variable in your, for example, game project. So you will have like a dictionary equal to load parentheses.